This presentation talks about applying process control engineering to national care delivery networks. My name is Derek Ritz. The presentation overview is as follows. We will cover what is digital health infrastructure and how does it impact upon population health. Then we'll talk about what are CCGs and how will they become digital health's game changer. By way of a very quick introduction, although I'm Canadian and have done work on domestic digital health projects, my experience and focus over the last dozen years or so has been as an advisor to digital health infrastructure projects in low and middle income countries. I've done this work on behalf of donor organizations like WHO, UNICEF, and the US government's PEPFAR program, among others. I'm a delegate of Canada to the ISO Technical Committee in Health Informatics and am Canada's liaison to IHE International. I'm also an HL7 Fire Foundation founder. Okay, let's answer our first question first. What exactly is digital health infrastructure? We'll use a story to help illustrate our definition. This story is about a migrant worker named Ramesh. Ramesh's health story has 3 chapters. In Chapter 1, Ramesh is feeling unwell. His malaria-like symptoms are noted by a community health worker in the village where he's staying. In Chapter 2, following the advice of the CHW, Ramesh attends a community clinic to have a rapid diagnostic test for malaria. Based on the results of the RDT, Ramesh seeks treatment at a district health center where he receives anti-malarial medicine. The community health worker in Act 1 of our story employed an mHealth application. The SMS messages were saved into the mHealth system's database. At the local clinic, the nurse used a basic electronic medical record system to log the results of Ramesh's rapid diagnostic test. When Ramesh saw the doctor at the district clinic and was prescribed his course of antimalarials, the information about his case was saved to the database of a Ministry of Health system dedicated to malaria care. None of these databases are connected to each other. Ramesh's information is trapped in separate information silos, and this is the problem that digital health infrastructure solves. It is an information sharing service that connects the silos and supports coordinated service delivery, two-way information flow, and continuity of care for Ramesh over time and across different care delivery sites. An example of such a digital health infrastructure service is the donor-funded, standards-based, open-source health information exchange, OpenHIE. So what are our key takeaways? Digital health infrastructure connects disparate health data. It is how we do systems engineering across a care delivery network. OpenHIE is an example of an IHE standards-based, open-source, low and middle-income country-focused data sharing architecture. It is the basis, in fact, of the national digital health blueprints in over 30 low and middle-income countries. Okay, but why do we care? How does digital health infrastructure impact upon population health? This diagram, which I call the loopy diagram, illustrates a process control-based model for how digital health infrastructure impacts upon health. Let's follow the arrows step by step. To begin with, health interventions yield population health. There's really nothing very controversial about this. However, I differ from some of my health informatics colleagues on the next point. The role of our digital health systems is to operationalize our health interventions. Digital health infrastructure is an industrial engineering intervention, not a health intervention. Its job is to help us be better and more efficient and more effective at executing our health interventions. When we leverage digital solutions at the point of care delivery, we generate person-centric transactional data. Here is where the importance of our eHealth standards is driven home. If we lay down our transactions in a computable format, we can aggregate them to generate population-level metrics. We can aggregate at whatever level we want. Data summarized about our subject of care is by definition a longitudinal health record for that person. We can aggregate at the provider level to support human resource management and payment schemes. If we aggregate at the facility level or the district level, we can support health system planning and management, and data aggregated on a national basis can be used to develop population level metrics and reportable indicators. Importantly, our metrics can be used to inform the fine-tuning of our digital health systems and the health interventions they support. This creates feedback loops. It affords us a way to exert process control and support continuous quality improvement. So, what are our key takeaways here? We improve population health by improving our ability to execute the health production function. We need to systematically close the no-do gap. Digital health infrastructure affords us a way to operationalize continuous quality improvement of the health system. So, what are CCGs and how will they make a difference? For those who have a process control background, the focus of CCGs is to operationalize feed-forward process control. Let's look at how that happens. Today, care guidelines are published as long narrative text documents that often read like a Cochrane analysis. The role of a computable care guideline, or CCG, is to represent the narrative text in a machine processable format that can be ingested by and understood by a software application. In this way, we can leverage our digital health investments to operationalize evidence-based care across an entire care delivery network to systematically close what WHO calls the no-do gap, or the gap between knowledge and practice. Systematically closing the no-do gap means maximizing the size of the green zone, where what was supposed to be done is actually done. In my own country, Canada, the impact of this is stark. A 2014 analysis indicated that medical errors kill over 30,000 Canadians each year. And an analysis done on a global basis showed that between 5.7 and 8.4 million deaths annually occur because of poor quality care in low and middle income countries, and this represents between 10 and 15% of the total deaths. To close the no-do gap, the CCG expresses three important things: the minimum data set needed to support the care workflow, the care workflow logic, including, for example, care escalation rules, and definitions of the reportable management indicators that can be automatically generated from the MDS. Importantly, CCGs are conformance testable. There is a way to establish that a digital health solution is faithfully and correctly operationalizing a CCG. The CCG strategy plays an important role in WHO's long-term plans. WHO, as a normative body, publishes over 50 care guidelines, and the organization is going through the process of converting those to SMART guidelines, or CCGs. And this plays into a larger agenda related to the establishment of a global learning health system. In step one of this agenda, WHO will publish its normative care guidelines as computable care guidelines. Countries will be able to take these up and adapt them for their own use within their own care delivery networks. These countries will then be able to leverage the person-centric coded data to do important analytics. These analytics can help them improve the operation of their care delivery network and also improve the care guidelines themselves. On a global basis, when de-identified content is shared back to WHO, it can use big data analytics and machine learning to start to improve the global CCGs, and this establishes a global learning health system. There's a team actively working to mature the CCG specifications. A first demonstration was made in January 2020 that showed that we're on the right track. The present capabilities have matured to the point where they're ready to be deployed in pilot implementations. And the vision going forward is that all care guidelines will be expressed in a computable format. What are the key takeaways here? CCGs are an instrument of feed-forward process control that can help systematically close the no-do gap. Going forward, our collective investments in digital health will help WHO in realizing its goals of establishing a global learning health system. Thank you for watching this presentation.